Okay, so we're doing chapter 9, problem 31. So we have a molecule of mass N and speed V. It strikes a wall at a right angle and rebounds back with the same speed. And if the collision time is delta t, what is the average force on the wall during the collision? So that was part A. So since the velocity changes direction, we know that the momentum is changing. But the final velocity is going to be the same magnitude as the initial velocity, just the initial or direction is different. So we know that average force here is given as the impulse or change in momentum over the contact time. So this is just mv final minus mv initial all over delta t. So if we take the final velocity to be in the positive direction and the initial in the negative direction, we have mv minus negative mv all over delta t. These become pluses, and this becomes 2 mv over delta t. That is our average force. Cool. Part B now asks, if molecules all of this type strike the wall at intervals a time t apart on average, what is the average force on the wall averaged over a long time? So instead of the actual time of interaction, we just use the time between collisions to get in order to get the average force, which means that we again have F average here is given as mv init final minus mv initial all over t. Now instead of delta t, this is the time between collisions. And again, this just comes out to 2 mv over t instead of delta t now. And this is, again, the average force.